Bismillahirrahmanirrahim. Assalamu alaikum, dear girls. How are you? Hope you are all fine. Alhamdulillah. Chapter 1, Electrostatic, we have completed. So now the ball is in your court. You are going to revise it well because coming Monday, you are going to appear in a test. This is the first test in second year, and first impression is the last one. So MCQs, short questions, maybe long questions, this would be included in your test. So good luck. I'm Sada Fishwak, and today I am going to discuss the exercise with you. In the previous lecture, I taught you the charging and discharging a capacitor in detail, along with the circuit diagrams and the graphs. Very important chapter, I must say. All the topics are very important, and you have to revise it well. After listening to today's lecture, you would be able to understand the MCQs, multiple choice questions, and some conceptual questions we are going to discuss. I am just giving you a hint. You listen to me carefully and try to do it yourself, all right? First of all, we come to multiple choice question. This is page number 53. This is the exercise of first chapter, that is Electrostatics, chapter 11. Now we come to the first MCQ. A charge capital Q is divided into two parts, small q and q minus q, and separated by distance r. All right? The force of repulsion between them will be maximum when there are four options: A, B, C, D, Q by 4, Q by 2, Q, none of these. And how you are going to answer it? Because there are two charges, we are talking about two charges. So definitely we are going to use Coulomb's law. And the first charge is Q1. That is Q1 is equal to Q2 when we say, because a charge Q is divided into two parts. So two parts means Q1 and Q2 are equal. Let me say that the charge is Q is equal to Q minus Q, and from this you have to find capital Q is equal to small q plus small q makes 2q. All right? So 2q is equal to capital Q. So eliminate for small q. It would be equal to capital Q by 2. All right? So which one is correct option? That is option B. Option B is correct. Number 2. Some charge is being given to a conductor, then its potential is maximum at surface, is maximum at center, remains same throughout the conductor, is maximum somewhere between surface and center. The correct option is remains same throughout the conductor. All right? C. Number 3. Electric potential of Earth is taken to be 0 because Earth is good. A, semiconductor, B, conductor, C, insulator, D, dielectric. The correct answer is conductor. All right? Earth is a good conductor. All right. Come to number 4. In number 4 option, you are going to solve it. A proton is about 1840 times heavier than an electron when it is accelerated by a potential difference of 1 kilovolts. So 1 kilovolt, definitely you are going to convert it into volts. Kilo stands for 1000. So 1 kV, 1000 volts. Its kinetic energy will be 1840 keV, 1 over 1840 keV, 1 keV, 920 keV. So in all the options, keV are given. That's why no need to convert into kilo. So which one is correct? In order to find the correct answer, definitely if you remember the equation I taught you in the second lecture, work done, W is equal to Q into delta V. Do you remember? And because this is a proton and electron, so you have to put Q is equal to small e. All right. And what is the potential difference of 1 kilovolt? So potential difference is 1 kilovolt. So when you put the values of V and Q in the equation, W is equal to Q into delta V. So Q means E. All right. E multiplied by W, E multiplied by delta V. So what is delta V? 1 kilovolt. So what we get? 1 keV. So the correct option is C, 1 keV. So from where? How you will find it? You will find from the equation W is equal to Q into delta V. All right. Come to fifth MCQ. A capacitor is charged with a battery and then it is disconnected. A slab of dielectric is now inserted between the plates. Then the charge in plates reduces and potential difference increases. B. Potential difference between the plates increases, stored energy decreases and charge remains the same. C. Potential difference between the plates decreases, stored energy decreases and charge remains unchanged. None of the above. Okay, the correct answer is option C. Potential difference between the plates decreases, stored energy decreases and charge remains unchanged. This I taught you right now, today's lecture. It was energy stored in the capacitor. Number 6. A 1 microfarad capacitor of a TV is subjected to 4000 volt potential difference. The energy stored in the capacitor is A. 8J, 16J, 4 into 10 raised to the power minus 3J, and D option is 2 into 10 raised to the power minus 3J. Okay, you are going to solve it and very clear in the given statement. A 1 microfarad, we all know farad is the unit of, yes, capacitance. So what would be C? C would be equal to 1 microfarad. Definitely you are going to convert it into farad. Micro means 10 raised to the power minus 6 farad. This would be C. And what is 4000 V? Yes, this is V. So any equation we use carrying C and V? Yes. In the previous lecture, that was lecture 8, where we calculated the energy stored in the capacitor, we use equation U is equal to half CV square. We are going to put the value of C and V there. So after putting the value, we will get the answer, and that would be 8 joules. So option A is correct. Come to number 7. In the figure, the charge on 3 microfarad capacitor is A. 5 microfarad, B. 10 microfarad, C. 3 microfarad, D. 6 microfarad. Okay, we are going to calculate charge, that is Q. You can see in the given figure, what is V? Yes, 10 volts. This is C1, C2, C3. And how the 3 capacitors are connected? Yes, these are connected in series combination. When these are connected in series combination, okay, we are going to calculate the charge. And how to calculate the charge? By using the equation for the capacitor. What is the equation? Q is equal to C into V. And instead of C, you have to write, yes, C equivalent. All right, because we are having 3 capacitors. So how to calculate C equivalent? Yes, for series combination of capacitor, what would be equation? I told you 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. When you will put it, you will get C equivalent. Right? That would be put in the final formula. Q is equal to C equivalent into V. C equivalent you will calculate it, and V is given here, that is 10 volts, and when you put all the values you will get the answer 10 microcoulomb. So which option is correct? Option B is correct. Come to number 8. The electric potential between 2 points A and B is delta V. Alright, there are 2 points, and across the 2 points the potential difference is delta V. The work done W by the field in moving a charge Q from A to B is A option, minus Q into delta V, B Q into delta V, C minus delta V over Q, D delta V over Q. So which option is correct? Yes, this one, option B. W is equal to Q into delta V. Very important equation. We have derived it, and we use it right now in the previous MCQ. We use this equation, I told you. So this equation is correct. Number 9. The electric flux through the surface of a sphere due to a charge Q placed at its center depends upon A, the radius of the sphere, B, the quantity of charge outside the sphere, C, the surface area of the sphere, D, the quantity of charge inside the sphere. So the electric flux, we are going to calculate its value through the surface of a sphere. Alright, so which option is correct? D option is correct. So electric flux through the surface of a sphere due to a charge Q placed at its center. It depends upon the quantity of charge inside the sphere. How much? Because flux, what is the formula of flux? Flux is equal to charge enclosed over epsilon naught. Alright, so here option D is correct. Come to number 10. Two parallel metal plates are distance 8.00 meters apart. So what is the distance between the two parallel plates? 8 meter. The electric field between the plates is uniform, directed towards right, and has a magnitude of 4 Newton per coulomb. If an ion of charge plus 2e is released at rest at the left hand plate, what is its kinetic energy when reaches the right hand plate? 4 eV, 64 eV, 32 eV, 16 eV. So eV, as I told you earlier, it is the unit of energy. All right, and here we notice we are going to solve it a bit. So what is D? D is the separation between the two plates. So D here is equal to 8 meters, and from the unit, Newton per coulomb is the unit of, yes, E, electric field intensity. So this is E is equal to 4 Newton per coulomb, D is equal to 8 meter. So what we get here, and one more thing, plus 2e. Plus 2e is the charge. So knowing the values of D, E and Q, where we have to put it? Yes, in the same equation, W is equal to Q into delta V. Alright, but we notice here delta V, we have to utilize, we have to convert it from the equation of potential gradient. As I told you, E is equal to delta V over D. By cross multiplication, delta V is equal to E into D. Alright, we are going to put it in the formula W is equal to Q into E into D. Alright, by putting the value of Q, E and D, what we get? You are not going to convert E, because E, in terms of EV, you have to calculate the energy. Alright, so when we put here all the values, what we get the answer 64 EV. Alright, so option B is correct. So hope you all understand. Now we come to conceptual questions, that is the short questions. And the first short question is, the electric potential is constant throughout a given region of space. Is the electric field zero or non-zero in this region? Explain. Okay, so there is some region, and in that region the electric potential is constant. As we all know, we are going to relate electric potential with electric field. So one and the only equation we derived in the topic, potential gradient, given by equation number 1. We all know this equation, we have derived it, if you remember. E is equal to minus delta V over delta R. Let it be equation number 1. But we notice one thing, that here in this question, what is given, that electric potential is constant. What does it mean? There is no change. Delta V is equal to 0. By putting delta V is equal to 0 in equation number 1, what comes? 0 over delta R makes the fraction equal to 0. Hence, what would be E? Is it 0 or non-zero? Definitely it would be 0. All right. Come to question number 2. If a point charge Q of mass m is released in a non-uniform electric field with field lines pointing in same direction, will it make a rectilinear motion? First of all, try to understand the question. There is a point charge Q of mass m. It is released where? In a non-uniform electric field. First of all, you must know what is a non-uniform electric field. I told you, yes. Is that field where the lines of force are not same. All right, they are not parallel. Maybe when you move along the field, the distance between the lines increase, or it may decrease. They don't remain same. It does not remain same. So in such a non-uniform electric field, you are releasing a charge. Its mass is given by m. Will it make a rectilinear motion? What do you mean by rectilinear motion? Means straight path. When a charged particle is placed in an electric field, definitely what happens? Yes, it will experience a force per unit charge, which is given by F is equal to Q into E. We know. As the field is non-uniform but pointing in the same direction, so it must be only due to a point charge, which is a radial field. So the point must be rectilinear. So the charge, it will make a rectilinear motion along the direction of the field lines. That is, maybe radially outward if it is a positive charge, or radially inward if it is a negative charge. Question number 3. What is the relationship between voltage and energy? More precisely, what is the relationship between potential difference and electric potential energy? First of all, we come to the relationship between voltage and energy. Voltage is the potential difference. All right. Derive relation for energy stored in a capacitor. We all know in the previous topic, in the previous lecture, we derived this relation. This is giving you the energy stored in the capacitor given by U. U is equal to CV square over 2. Right? In this relation, we notice one thing, that U is directly proportional to V square. This is a relation which exists between. So relationship between potential difference and electric potential energy. Derive relation for work done when charge is moved between two parallel plates. And if you remember, if we are having two oppositely parallel charge plates, one is A, other is B, and if you are moving the charge against the field, you have to do work done per unit charge. That gives you delta V, that is potential difference. All right, and from this relation we also know that delta W, this work done, is stored in the form of energy known as electric potential energy. So here we can use delta V is equal to delta U over Q naught. So what does it mean? It means that delta U is directly proportional to delta V. These two are depending on each other. Number 4. Voltages are always measured between 2 points. Why? Voltage or electric potential is defined as the amount of work done in moving a unit positive charge from one point to another in electric field against the electric field intensity. Electric field intensity means against the field. It means that potential difference is measured between 2 points. It is an arbitrary. So potential difference is calculated in between 2 points always. One point is taken. One point is always taken as a reference point, and with respect to this point we compare it with the other. So definitely we cannot measure the potential difference at a single point, because these 2 points are relative points and it is always measured in between 2 points. For a single point, it is not possible to have 2 different values of potential. What is needed for the potential difference? As it is clear that potential difference gives you the difference between the 2 points carrying 2 different values of potential, which is always possible if there are 2 different points which are taken. Question number 5. How are units of volts and electron volts related? How do they differ? Potential difference of 1 volt exists between 2 points when 1 joule of work is done in moving unit positive charge from one point to another, keeping electrostatic equilibrium. This I told you, you are going to use this equation for volt, and 1 volt is equal to 1 joule of work for 1 coulomb of charge. 1 electron volt is the amount of energy acquired or lost by an electron with potential difference of 1 volt. So delta U is equal to E into delta V. Basically this is the equation, delta U is equal to Q into delta V, because here we are talking about an electron. So we put Q is equal to E. So when we put it here, what comes? This relates electron volt and joule. Here you should draw a figure also. One plate is A, positively charged, other is B, negatively charged. Definitely you are bringing an object against the field, so that's why you have to do some amount of work done, which is known as volt. So this gives you the relation between electron volt and joule. Electron volt is the unit of energy, whereas volt is the unit of change in energy per unit test charge. That is potential difference. Question number 6. In what region of space is the potential due to a uniformly charged sphere the same as that of a point charge? And what region does it differ from that of a point charge? Okay, outside the charge sphere, the value of the potential is given by V is equal to Q over 4 pi epsilon naught R, which is same due to a point charge. Which Q I am talking about? Inside the charge sphere, as I told you, according to the application of Gauss's law, there is no charge enclosed. So E is equal to 0. There is no field inside the charge sphere. So that makes the expression from where it comes, potential gradient. E is equal to delta V over delta R. So eliminating for delta V, what we get? Delta V is equal to E into delta R, because E is 0, putting 0 into delta R makes delta V is equal to 0. So delta V is equal to 0 is coming. Hence V, what we conclude? That V is constant, which is not same as due to a point charge. Number 7. Can the potential difference of a non-uniformly charged sphere be the same as that of a point charge? Explain. Outside the charged sphere, potential of a non-uniformly charged sphere cannot be the same as that of a point charge, but in special cases when points is far from the sphere, then we can take it equal to the potential due to a point charge. This is a special case. Inside the charge sphere, charge has different amount in different parts of the sphere, and there would be a resultant electric field in the interior of the sphere. So electric potential is same as that of a point charge. Question number 8. What is an equipotential line and equipotential surface? Here you can draw the figure as it is given in the book. See the topic, equipotential lines and surfaces. I told you. An equipotential line is a line joining points having the same potential, right, in the form of a circular path. And at all the points on the circular path, the distance of the point with respect to the charge remains same, showing same potential. Any surface with same electric potential at every point is called equipotential surface. In the end, again a quotation by Albert Einstein: a person who never made a mistake never tried anything new. Okay, good luck, girls.